Hi guys, welcome back. I am here with another flashcards video for you to help you study for the physics GRE, and hopefully you will find this helpful. If not, I'm sorry. This is just what I used when I was studying, and you can see my other flashcards videos for more information, and there'll be a link below for a PDF so you can print these out or use them however you desire. So today we're going to be doing laboratory methods, which is a pretty short section and a very kind of eclectic one, so we should get through these pretty quickly, and yeah, happy studying! The Compton wavelength says lambda equals h over mc. Gaussian sigma, this is basically what that means. So x plus or minus sigma means that 68% of it is going to be within the sigma. So it's just a definition of what 1 sigma means. Pair production. So this is when energy in your nucleus induces a photon to produce electron-positron pair, and so the energy of the photon has to be greater than 2 times the mass of the electron c squared, and this is dominant for high energy photons, that's greater than 10 mega electron volts, and the probability is proportional to z squared. It's kind of just a very quick overview of pair production. There's a lot of different information on there. I told you this is an eclectic site. All right. Log-log plot straight line. So basically, what does a straight line mean on a log-log plot? Well, that means that you have a function that is the form of y equals ax to the b, where b is the slope of the line on the log-log plot, and a is the x value, the y value at x equals 1. So not the intercept, but at x equals 1. Because remember, it's log-log. Logic gates, so this is kind of hard to describe because it's pictures, but basically there are 4 that you should know: AND, OR, NOR, and NAND, and basically the NOR and NAND have the little circle at the output. That means that it's a negative, and then AND is a kind of triangle. I don't know how to describe this. I'll just show you the pictures. A 3-level laser. So level 3 is the excited state that is reached by pumping, and level 2 is the metastable state, and then level 1 is just the ground, a level between ground and level 2. So you pump up to 3, and then it goes down to this metastable state. Poisson distribution. The formula for this is P of n equals lambda to the n e to the minus lambda over n factorial. And so for n equals 0, it's just e to the minus lambda. A high-pass filter. So this is actually a circuit drawing. And so for a high-pass filter, you're going to have V in and then a capacitor and then a resistor to ground and V out. Or you can have V in, a resistor, and an inductor to ground and then V out. Compton scattering. Excuse me. This is when a photon scatters elastically and then the electron is ejected. So this is dominant for medium energy photons, 10 kiloelectron volts to about a mega electron volt, and the probability is proportional to z. Weighted averages uncertainty. So the x value will be equal to x divided by sigma x squared plus y divided by sigma y squared divided by 1 over sigma x squared plus 1 over sigma y squared. And then the total uncertainty is going to be 1 over sigma x squared plus 1 over sigma y squared. A diode. So in a diode, no current flows until the bias voltage is reached. The voltage drop is mostly independent of current, and it's used in part of a rectifier circuit, that is something that goes from AC to DC, alternating to direct current. Poisson measurement error is approximately the square root of n for large n, where large n is greater than about 20. An op-amp. An op-amp is in an op-amp, the output voltage is proportional to the difference in the input voltages. And if that difference is too large, the output saturates, and so you get clipping. The binomial distribution is used when you have a fixed number of trials with binary outcomes. And I didn't write down the actual equation, so I guess that was not something I was worried about. Okay, propagation of error. So if f equals little a times big A, then the uncertainty on f is equal to a times the uncertainty on big A. So a little a is just a constant here. If f equals big A plus big B, then the uncertainty on f is the square root of the uncertainty of a squared plus the uncertainty of b squared. And if f equals a times b or a divided by b, then the uncertainty is equal to the square root of the uncertainty of a divided by a squared plus the uncertainty of b divided by b squared. Time between Poisson events. So P of t is equal to lambda e to the minus lambda t, where lambda here is the rate, the Poisson rate. Sample variance. So this says that sigma s squared is equal to 1 over n minus 1 times the sum from 1 to n of x sub I minus x bar squared. So if you have a set of n samples, this is what the variance is. Photoabsorption. So this is when a photon is absorbed and an electron is emitted. The maximum energy is equal to the energy of the photon minus phi, where phi is the work function. And this is dominant for low energy photons, about a kilo electron volt, and the probability is proportional to z to the fourth. De Morgan's law. So this is a logic thing, and it says that the inverse of A and B is equal to the inverse of A or the inverse of B, and that the inverse of A or B is equal to the inverse of A and the inverse of B. So this is basically how nans and nors relate. Wavelength shift due to Compton scattering. Delta lambda equals h over mc times 1 minus cosine theta, or theta is the Compton angle. A low-pass filter. So again, this is a circuit drawing, so basically you have voltage in, a resistor, and then a capacitor to ground and voltage out, or you have voltage in, an inductor, a resistor to ground, and voltage out. A low-pass filter. What does a straight line mean on a log linear plot? That means you have a function that takes the form y equals c 10 to the bx, where c is then the y-intercept of that straight line, and b is the slope of that line. Total lifetime due to multiple decay channels, Total lifetime due to multiple decay channels. So basically 1 over tau, which is total lifetime, is equal to 1 over tau 1 plus 1 over tau 2, etc., etc., where those are the different decay channel lifetimes. The number density for radioactive decays is that n equals n0 times e to the minus t over tau. Exponentially decaying. And lastly, a Michelson-Morley interferometer. So here I just have a sketch of how that works. So you have a light source coming into a diagonal half-silvered mirror. And so some of the light goes up to and is reflected off mirror A, and some of it passes through and is reflected off mirror B, and then it comes back to that half-silvered mirror, and then some light is reflected into the detector. Sorry. Here's my drawing. Yes, and then it's an interferometer because the light then interferes because of the different path that it took. And that's it for laboratory methods. Hopefully that was helpful for you, and I wish you all the best on your test and with your studying, and good luck to you. All right, I'll see you again soon.